Today we're going to be talking about functions and transformations. As an introduction, I'm going to be talking about what transformations are and explaining them. And then I'm going to be talking about the different types of functions, a few of them, and I'm going to be talking about how these transformations work in these functions. And lastly, I'm just going to give an example to make everything a bit clearer. So what are transformations? Well, as the name suggests, they transform the base function. So the y value is going to be affected by a and k, and the x is going to be affected by b and h. And you might be wondering what these new letters are. Well, I'm going to be explaining them in future slides, and I'm going to be referring back to the slide so you understand where the connection is. But for now, you just need to understand these parts. Absolute A will vertically stretch the base function by a if it is bigger than 1. However, it will vertically compress the function if it is between 0 and 1. So what this means is basically just like the slope. It just changes how the base function looks. B is basically the same thing. However, it is affected by x, as you can see. And instead of vertically, because it is x, it will horizontally stretch or compress, and with the same types of rules. An easy way to remember this is when a teacher is asking if this is vertical or horizontal stretch or compression, you can just remember as because y is affected by a and y axis is vertical, you can just remember that a will vertically stretch. And the same for b, because it is correlated with x axis, then it will horizontally stretch or compress. And then now is the more important parts, because for k and h, these are a lot easier to graph. You can see that k is correlated with y, so it will move up by k if it is positive and move down by k if it is negative. Same for h, and it will move right if it is positive and then move left if it is negative. And the reason why k and h is more important, as I said before, it's a lot more tangible when you graph it, and it's a lot harder to graph compression or stretches. So now on to some types of functions. Some words to just remember is that to the power of 3 is cubic, and to the power of 4 is quartic, and to the power of 5 is quintic. And although I only introduced the quadratic, which is 2, these are just some numbers so that you know what the powers are. And so now just to clarify how a, b, h, and k work inside of functions, if you just glance at all of them, they are mostly similar. However, they also have some slight changes. But if you just take the base one, the linear function, you can see that it's fx equals a in brackets b, and another set of brackets x minus h in double brackets plus k. And although there aren't any y, and you might be wondering how a and k would even affect y if it doesn't even exist. Well, y is basically just fx. And what f stands for is just the type of function that is affecting x. And you can see that x here is basically in brackets, and x here is also in brackets. And then if you see that what is outside of brackets is a and k, then you know that if fx is basically just y, then you can basically just replace all of these brackets by y, and you can see that a and k are affecting y. So then again, you see that a and b are going to be stretching or compressing, and then h and k are going to be moving it left or right or up and down. So I'm just going to be going through the rest and talking about what the small differences are. So the quadratic function has a difference because it is to the power of 2. And again, if you aren't convinced that fx is just all of these brackets, f basically stands for function, and function is, although all of these are basically the same, the x are always affected some way or another by what we call a function. So you can see here, although x isn't affected by anything, the function is still just being affected by b and h. However, over here, the function also includes to the power 2. So you know that all of this would just be x, and then the rest are going to be affecting the y. Over here, this is called the radical function. Most people call it the square root function. However, it doesn't only apply to square root. It can also be to the cubic root and etc. However, we just put square root here. And you can see instead of a exponent of 2, we have a square root to all of this x. And then a rational function, and as the name suggests, there are division signs, which is just a divided by all of this x and what is affecting x, and lastly plus k. And then for the last function, you have an exponential function, and you might see here there isn't any a, and it's actually replaced by e, because what the exponent is actually just x. So e is part of the base function, therefore exponent functions can have many different forms. E can be 1 or 2 or 3 or 4, and those are all of its own base functions. So this is just a real number to the power of x and whatever is affecting x, all of that plus k. So one thing to note is that I think I'll be talking about this later, but you can see that this is negative h and this is plus k. So it's important to remember that although if it's x minus h, h is actually going to be positive because it is just normally negative inside of the function. So now I'm going to be talking about an example. I'm going to be using an exponential function, which you can see here the base function is 2 to the power of x. The base function without any transformations, you can see here it has a 2. So therefore you know that it can also be like 2 or 3 and etc. So the question is going to be, what transformations are there to get to fx equals 2 to the power of negative x plus 6 minus 5? So I'm going to be working a little bit backwards here, and I'm going to be talking about the h first. So from the previous side, you can see that h is the one right next to x. So at the start, you might think that, oh, h is going to be negative 6 because, as you can see here, h is supposed to be originally negative. So to get 6 here to appear positive, h actually has to be negative. So let's say if it's x minus and h is actually negative 6, it will appear as x plus 6. We can see here there's also a negative sign, and there aren't any negative signs in this exponential function type of rule that you have to go by. So therefore you know that you have to get rid of this negative because x has to be positive and it also has to not have a coefficient. So if you get rid of x throughout this entire bracket, then you can find that, oh, 6 is actually going to be negative now, because although appearances might be deceiving, you might see a positive 6 here, it's actually going to be a negative 6. So therefore, if we know that what's inside of these brackets, x and h is supposed to be x minus 6, and you can see there, because h is supposed to be naturally negative, then h is by itself positive. Therefore, know that h is just going to be 6. Therefore, because it is positive, you'll move right by 6. And then, now that we found out that this is actually a bit deceiving, and this is what the simplification uh, is, you can find that b is -1, and it just makes this entire graph reflect on the y-axis, also known as just flipping horizontally. And lastly, you can just see this is a -5, and unlike this, it isn't supposed to be naturally negative, so you can just know that this is -5, and you'll move down the entire graph by 5. The red line, the red function, is just the base function 2 to the power of x, and then the blue one is just the base function after the transformations, which is this function that we've worked through. You can see that here it is flipped horizontally, and it's moved down 1, 2, 3, 4, 5, and it's moved right 6. 1, 2, 3, 4, 5, 6. And if you know how to do this, all of the rest, all the other functions will look very, very similar, and you should have no problem going through transformations.